Hi, and welcome to the Data and File Management Community App Introduction tutorial. Here's OpenSat Kit's main screen. The middle section of the first tab contains links to application groups. I'm selecting the Data File Management application group. The apps in this group manage telemetry data, files, and file transfers. On the right side panel, there's access to each of the app's commands, telemetry, tables, and users guides. In OSK version 2.5, the CCSDS File Delivery Protocol app was added. TFTP is still OSK's default file transfer mechanism. However, CFDP is fully accessible for use in scripts and through Cosmos tools like Command Sender and Packet Viewer. At the bottom of the screen, the Functional Screen section provides links to screens that are focused on achieving goals that may involve multiple apps, or also tools, as in the Create TO Table tool. The Learning Resource section provides access to demos and tutorials like this one.
In this tutorial, I'll introduce each of the file and data management apps, describe how these apps participate in real-time and playback telemetry, describe the SimSat reference mission scenario and how the apps are configured to be used within that context, and then run an OSK demo that uses the SimSat configurations.
There are 5 apps in the Data and File Management group. File Manager is like the Windows Explorer ground interface. It provides commands for manipulating directories and files, and it allows users to obtain information about directories, files, and file systems by requesting one-time telemetry packets or dumping information to a file. Housekeeping combines subsets of multiple source packets into new packets. The new packets are generated when an output packet command is received. This command is usually sent by the scheduler, and the timing of the command should be based on the timing of the source packets. Data storage receives messages from the software bus and writes them to files. Table parameters determine which messages are stored in which files. Data storage does not have a message playback feature. OpenSat Kit contains 2 apps for transferring files between the flight and ground. The CFDP app is a NASA open source app that implements the CCSDS File Delivery Protocol, which was designed for flight. All of the protocol packets are transferred via the command and telemetry interface, as opposed to relying on a network interface such as UDP. OSK uses Visiona Space's Cosmos CFDP engine. The Trivial File Transfer Protocol app was specifically written for OSK, and it uses UDP. It's not suitable for a ground-to-flight interface, but could be used for onboard interprocessor file transfers, as long as both processors have a network stack. Here we see the telemetry packet data flow. Blue apps are NASA open source apps, and green apps are OSK apps. The upper left group of apps represents any app that generates telemetry packets. These are called real-time telemetry packets, represented by green arrows. If needed, housekeeping can be configured to create new real-time telemetry packets. Real-time telemetry can be downlinked via the telemetry output app, and also stored on the recorder using data storage. CFDP is used to transfer telemetry packets stored in files from the recorder to the ground. These telemetry packets are referred to as playback or non-real-time telemetry. The tables highlighted in yellow indicate that a tool can be used to automatically generate the table. Determining which telemetry packets should be stored and which should be downlinked in real-time telemetry often requires some analysis, especially if the mission has different communication scenarios with different downlink rates or contact periods with a downlink but without an uplink. OpenSat Kit version 2.5 includes an example telemetry analysis spreadsheet and a tool that can take a comma-separated value file from the spreadsheet and generate KitTO packet tables and data storage. This diagram shows how the apps are configured for SimpleSat, and a demo will follow. Housekeeping is configured to create 2 packets. The first combo packet includes the command counters from each of the CFE service apps. The second combo packet combines instrument status data from ISIM and attitude control data from F42. This packet serves as auxiliary data for the ISIM science data. Data storage is configured to create 2 files. The first file only contains event messages, and the second file only contains the science auxiliary packets from housekeeping. All of the files are stored in the SimSat recorder directory. The instrument simulator app, ISIM, directly writes its science data files to the recorder. CFDP is used to transfer the files from the recorder to the ground. The files are automatically deleted from the recorder by CFDP after they are successfully transferred. This is called a Class 2 transfer. Telemetry output downlinks both real-time telemetry and playback files. 2 TO packet tables are defined for different downlink rate scenarios. I've already started the CFS, and now I'm going to open the data file management demo. This brings up a screen that will be used to step through the demo. Before I start the demo, I'll explain the telemetry items on the page. First, we have the instrument simulator, and this identifies the instrument state, whether science data is on, and science cycles. And science cycles are just, it collects one sample every second and then creates a file every minute. Here's our housekeeping data, and as you can see, we're creating the housekeeping packets already. Now this missed data count's going up because the F42 application is actually not running, so we're not getting the controller data into that auxiliary science data packet. Here's our data storage. The state is enabled, but there's no open files. That's because we're going to send a command to enable these particular files start to be generated. And for each file, you have whether it's enabled, if it's open, its sequence count, its age in seconds, and then its size. For the recorder, this section is for the recorder, and we have the file count, and this is actually from a file manager packet that's periodically being solicited in the background. Then there's a little graphic here, and if I hover over it, it will give me the limits, and I just set up a graphic here to say, oh, there's 15, if you can have 15 files in this recorder, and a red and yellow just to kind of let us have some limits to graphically look at. And then over here, we're going to see the actual file names of the current file being written into the recorder. And this bottom section is for the file transfer and downlink. The kit TO will always be computed. One note here is that although there are tables for different rates, there's actually no throttling mechanism between CFDP and telemetry output. So the rest of the packets are configured to match a particular rate with then some portion of that rate set aside for file transfer. But in reality, we're not really going to see the exact rates or anything because of the whole system's not been tuned in that way yet. And then here we have the two different options for TFTP or CFDP, and we'll see that these send counts go up appropriately. So let's go ahead and start the file generation. So if we go over here, we're going to start seeing science data instrument is powered on. So it's starting to initialize, and this just has a startup period to simulate, perhaps a real instrument warming up, and then science data can then be enabled after it's reached its proper temperature. We now see that the science instrument's in the ready state. Science data is on. We see the science cycles incrementing as we expected. Data storage is now enabled, and we now have our files that are being created. So our first event file is being created. We're on our first ISIM science data file, and we're starting to see auxiliary files. Now the file jumped to 6 because before this demo I hadn't actually deleted all the files in the recorder, so we're actually towards the higher end of our green limit. And we can see KitTO is producing some rates that are well under the rate specified in the table, and right now we haven't done any file transfers. So now we're just going to wait for a little while and let some files be generated, and then we'll be able to start our playback. We now see that we have plenty of files, so we can start the downlink. I'm going to select CFDP, and I'll set this to 32 kilobits, and now we'll start the downlink, the playback. So the first thing that's going to happen, it's going to turn off the science data, and this way we don't have to worry about, this wasn't set up for, if you had a hot directory with only closed files. So I actually stopped file creation, so all the files in this recorder directory are closed. Now it issued a CFDP command to downlink all the files in a particular directory. So we see now that CFDP has queued up 14 files for downlink, and we see that a transmission is currently in place. So now it's going to keep going through and transferring each of the files. If I move this over, we'll see that it's downloading the events file, the ISIM file, an events file. I can make this bigger. And it's going to keep going through until we downlink all the files. So this concludes the data and file management introductory and demo. I hope you found it helpful, and additional videos will go into more detail for each of the apps in the table generation tool. Thanks for tuning in.